All right, so and this slide shows just how to prepare solution if we know the concentration and we want to prepare solution, because we will do it in the lab basically, and I just want to show it quickly, but in the lab I'll explain all these things. So we have here cobalt chloride hexahydrate. So this is dehydrate, I'm sorry. So we have cobalt chloride dehydrate, and we want to prepare solution of this cobalt chloride dehydrate. So first of all, we need to know what is the molarity. So we need to know molarity. So which is moles per liter, right? So then we need to prepare the solution, right? Say we have a bottle volumetric flask, which is 500 milliliter volumetric flask. So it means that it can take 0.5 liters of water, right? So it's a half a liter volume. So, and for example, we need to prepare one molar solution. So this capital M means that this is molarity, which means that this is moles per liter. So first of all, what we need to do is that we need to find the number of moles. Also, we already know number of moles for this.
Doctor,
Yeah.
can I ask you something?
Yeah. What is it about?
The quiz, doctor, that we presented was of only 2 marks, but it's
Yes.
written in the model that we will present 4 quizzes, and each of them has 5 marks.
It should be 0.5 marks. So then it's going to be 2 marks overall. Each question is 0.5.
0.5?
Yes. Each question is 0.5 marks.
I know, but in the all seminar, in the all semester, we take just 4 quizzes.
Okay,
And
so what you are asking, I don't understand. We are talking about concentration here. So is your question about concentration?
no, about the quiz.
Okay, about the quiz, send me an email. So we are talking about concentration now. So we cannot
Okay.
like go back and forth with topics. So send me an email about that. Okay, so let's continue about this issue. All right, so then we need to find out, since we have 1 mole of copper chloride in 1 liter of solution, right? So we need to find out how to make this solution. So it means that we need to calculate the mass of copper chloride dehydrate, because we cannot measure 1 mole on balances, right? So we have balances. We have balances, and we need to measure. We need to measure the mass on balances. Also, we know that we have only half a liter of volumetric flask. So it means that if we have 1 mole in 1 liter, it means that we should have 0.5 moles, right? 5 moles, 0.5 moles in 500 milliliter. Because we have only 500 milliliter volumetric flask. So we need to take a half a moles of copper chloride. Then we will calculate how much is this half a mole in terms of mass, because we need to measure it on balances, right? So we just calculate the mass of copper chloride, then we just measure it on balances. After that, we will transfer it to the volumetric flask. Then we add some water, a little bit, to dissolve it first. And then we just dissolve it completely, and then we just add water to the mark. This is how we prepare the solution of a given concentration. If the salt is not very soluble, then we better dissolve it first. So we measure the mass, then we dissolve it in a beaker, okay? And then we put it in here. So it's better to do like that. Okay, let's just, do you guys have questions about all these things? Okay, so then let's just go into more details. I'll share different file with you, which we started from the very beginning, and let's just go through this in a little bit in more detail. So last time, which was lecture number 2, we discussed about anemia, if you remember, so which is limiting reagent, right? So it's about limiting reagent, and we talked that if there is not enough iron in the organism, which is related to hemoglobin, then it can cause anemia. Why? Because the blood cannot distribute the enough oxygen to tissue, right? So then it can, cause some kind of problems in the organism. So the same thing can happen if we have lack of oxygen. Okay, not only iron, but also oxygen, because hemoglobin binds oxygen. And if we do not have enough oxygen, then the same problem can be. Okay, so for example, if you look at this slide, it's about the situation in high altitude. So in high mountains, the pressure, the pressure of air, partial pressure, so-called partial pressure of oxygen is very low. I mean, it's not very low, but it's lower than in normal ordinary situation. And as we discussed, so the pressure really affects on solubility, right? So if we have low pressure, then oxygen cannot be dissolved well in blood, and basically blood cannot distribute oxygen to tissue efficiently, okay? So it means that, again, the hemoglobin cannot bind oxygen because we do not have enough oxygen because of low pressure of partial pressure in high altitudes, for example, right? Or say under the water. So so when you say if you're under the water, so there is not enough oxygen because there's very small amount of oxygen in water, right? So you cannot breathe in there. So the same thing can happen, but you need oxygen. So this is why we cannot stay under the water for long, right? So because we do not have enough oxygen. So again, it can cause this gonna be limiting reagent in this process. So in this particular case, oxygen is a limiting reagent. So we also discussed about chemical equations and what does it mean, the stoichiometric coefficients in front of that. And also I want to discuss about chemical equations in terms of balancing of this chemical equation. You can see here that, say, if we oxidize hydrogen using oxygen, right? So we're creating water, right? We have particular amount of molecules from left-hand side, right-hand side, and all this amount taken together from right-hand or left-hand side is 36.04 grams of reagent. So if you add these two, you will have this amount of reagent. So in terms of grams, right? If you look to the right-hand side, if you just calculate the mass of 2 molecules of water, you're gonna have the same amount of product. So it means that whatever you take on the left-hand side, amount of chemicals, you should end up with exactly the same amount on the left-hand side in terms of mass. We discussed about moles, right? So we need to balance the equations. We need to have right coefficients, but also we should remember that in terms of mass, we should have exactly the same amount of reagents on right and left hand side. So it's basically law of conservation of mass. Okay. The same thing is here, so you need to balance the equation and then just to see if you have the same amount right and left hand side. Let's just discuss about particular example how we find some information after we write the chemical equation. We balance it, we find out the number of moles, number of, okay? And then we find out some kind of other information. For example, we have production of ammonia, right? So we have nitrogen plus hydrogen and we make ammonia. So we need to take 1 mole of nitrogen, we need to take 3 moles of hydrogen, we need to, and once we do so, we obtain 2 moles of ammonia, right? Now we have a question. So say we have 16 grams of hydrogen, which completely reacts with nitrogen to form ammonia. It says how many grams of ammonia will be formed. This is what we need to find. Okay, so we know only initial amount of hydrogen. Now let's just think about this and discuss how to find.
Can you repeat the question, please?
Yeah, the question is written here. So there's the question. This is the question. Let's just think a little bit and then let's just follow the logic which we have here. Okay, so it says that to do this calculation, to find how many grams of ammonia we can produce if initially we have 16 grams of hydrogen and it completely reacts with ammonia, for example. I'm sorry,
5.3
with nitrogen.
grams.
I don't know. Let's see together. So I really don't know. Let's just follow the flow. So what we need to know is that we need to first convert grams to moles. For example, we can take this kind of approach. So we need to convert grams of hydrogen to moles of hydrogen. Then we need to, once we convert it to moles of hydrogen, then we can convert it to moles of ammonia, and finally to grams of ammonia. Okay, so conversion we have is that grams of hydrogen, which is this one. So we need to find how many moles of hydrogen we have from 16 grams. Then we need to convert it to moles of ammonia according this reaction here. Okay, and then once we find the number of moles of ammonia, we can find the grams of ammonia. That's the, say, approach. So how to convert 16 grams of hydrogen to number of moles of hydrogen, right? So what we need to use is we need to use molar mass of hydrogen, right? So we know that, so we have unit grams and we have unit grams per mole. So how to use all these parameters in order to make moles, right? So we need to basically use these 2 parameters in order to somehow end up with moles, right? Okay, so number of moles of hydrogen is going to be 16 grams of hydrogen multiplied by 1 over 2.1016 grams of hydrogen. Okay, so how we get this number? Let's just look at this one. All right, so okay, so what is the molar mass? What we know, what is the molar mass of hydrogen atom? Do you guys remember?
Yes, a gram per mole.
Yes, so 1 gram per mole, right? 1
gram
gram
per mole, right?
per mole. Yes, exactly. So, but we do not have just only atom of hydrogen, right? So we have H2.
It's
Right?
2 grams, 2 mole.
Right, so it's going to be 2 grams per mole. So it's going to be 2 grams per mole. Okay, so to find the number of moles, if we know the grams of hydrogen, we just need to divide grams on molar mass. Okay, this is what we need to do. So say if we divide 16 grams on 2 grams per mole, right? 2 grams per mole, we're gonna add with 8. What's gonna be the unit here?
Mole.
Yeah, exactly. It's gonna be moles. Okay. How? So now look at this one. This is basically written the same. Only thing is that they, instead of like dividing 16 on 2 grams per mole, they just multiplied it on the reverse of 2 grams per mole. So they just, it's the same thing. So you divide this by this. That's the same thing, exactly the same thing, right? So you can rewrite it like this way: 16 over 2, what we have here. Okay, so we just make a little bit like, you know, approximately, they exactly calculated this number. So it's 7.94 moles of molecules of hydrogen. Okay. All right, so now they know what is the amount of hydrogen of 16 grams in terms of moles. So this 16 gram corresponds to this amount of moles of hydrogen. Okay. Now the next step is that, okay, we already found this one. So we found this step is known. Now we need to find this one over here. Ammonia, number of moles of ammonia. How we find this one? Please look at the equation. It says nitrogen 1 mole plus 3 moles of hydrogen. We create 2 moles of ammonia. This is ammonia over here. Okay. So it means that 3 moles of hydrogen, say like that way, 3 moles of hydrogen produces 2 moles of NH3, right? So this is how we have this proportion according to this equation. But in reality, this is just on the paper. So this is according the reactions, the theory and everything, okay? But it's very important to know. This is how it goes. This is a proportion which is written on the paper, right? But in reality, we have 7.94 moles of hydrogen, right? So it means that 7.94 moles will produce X moles of ammonia, right? So how to find X? So it's written over here. So that's the same thing. Okay, so we just multiply.
Doctor,
Yeah.
can you repeat it, please?
Which part, please? Which one is need to be repeated?
7.94 mole.
Yeah, so 7.94 moles is a hydrogen. According 16 grams. So if we have 16 grams of hydrogen, it means that we have 7.94 moles of hydrogen. How did we find it? We found it using this equation here. So what is this? This is the given amount of hydrogen, and this is the molar mass of hydrogen. Okay, so we use mass of hydrogen and molar mass of hydrogen to find the moles of hydrogen. Okay. After this, is it clear?
Yes, it's clear.
Okay, after this, from the equation, we know that we have 3 moles of hydrogen producing 2 moles of ammonia. So which means that 3 produces 2. So it means that if we have this ratio, then we can find what's going to be production when we have 7.94 moles of hydrogen. So it's going to be X number of moles of ammonia. Okay. So how to find this X? We multiply 7.94 by 2 moles of ammonia and divide by 3. This is what is written here. So 7.94 by times 2 divided by 3. It's going to be 5.29 moles of ammonia. So it means that we found now this. You know, maybe we should erase all this stuff because it's too much here. So I'll just put all these things on Moodle so you can just find it in there. So this recording. So now we calculated this one here. See, this is what we calculated. Now we need to, the last step is to calculate the grams of ammonia. Okay, the grams of ammonia. How to calculate the grams of ammonia? What do we need for that? Has anybody have an idea?
Molar mass?
Yeah, we need to find molar mass of ammonia. So that's the molar mass over here. So 1 mole of ammonia is 17 grams of ammonia. This is what is written here. And then we just multiply number of moles by molar mass. So we just multiply number of moles by molar mass, finding the amount of ammonia, okay? Which is 90 grams, about 90 grams of ammonia. So we found that if we take 16 grams of hydrogen, we will get 90 grams of ammonia. Is that clear, all these things here?
How we know 1 mole is 17 grams?
Okay. Did you do the quiz?
Yes.
How did you find the molar masses in there? Did you do
Okay,
it by yourself?
Yeah.
So how did you find the molar masses there? There's the same thing is here.
Okay.
Any other questions? All right, so let's just continue some more practical stuff. Let's just look at this one. I want you to think, please read the written in the blue in this kind of the food we eat is degraded or broken down in our bodies to provide energy for growth and function. A general overall equation for this very complex process represents the degradation of glucose. This is the glucose. And once it degrades, it goes down to carbon dioxide and water. So that's the reaction we have. This is the reaction we have after degradation of glucose under influence of oxygen. That's the glucose over here. So that's the glucose, and we, as a product, we are getting carbon dioxide and water. So I want you to think, if we have 968 grams of glucose, which is consumed by person over a certain period, what is the mass of carbon dioxide produced? So if the person uses this amount of glucose, he produces some amount of carbon dioxide. So we need to find the amount of carbon dioxide produced. So think about this one. Then we'll just try to find it out. I'll give you a couple of minutes.
We will do the same thing that we do it in the last question.
It's a very much the same. It's a very much the same, but I want you to actually tell me what is that same. Exactly, in terms of like numbers and everything. So think about that one and then we'll discuss. All right, so let's just take a look what's gonna be the outcome. So what is the first we need to do? Can anybody say that?
Doctor, I think we multiply 12 by 6 and add 1 multiplied by 12 and add 16 multiplied by 6.
And what is this one? What we want to find by this?
Molar mass.
The grams. The molar gram.
Yeah, so we need to find molar mass of what?
Doctor, then we want
The
Yeah.
glucose, right?
Of glucose, yeah. So please, can you
Yeah.
tell me what's gonna be the molar mass of glucose? Can you calculate this?
This equation on the screen or what?
No, just tell me, just calculate and then I'll write it here. So what is the molar mass of glucose?
If you do this calculation, it will be 180 grams.
Yes, 180 grams. What is the unit?
Mole,
Right?
Gram to mole.
Gram
to
per
mole.
mole. Gram per
gram.
mole. Yes, gram per mole. This is very important to write the unit. Gram per mole. Okay. So what is the next after this?
We divide 180 by 986,
Right. So why do we want to do that?
so we can know the mole of the person, I guess.
Right, of glucose, right? So we want
Yes, of
so to
glucose.
find the moles of glucose, we divide 968 grams. We'll divide by 180 grams per mole. And we will what is the number here?
5.3.
5.3
5.3.
mole, yes.
Yes, more.
5.3
Okay,
mole.
5.3 moles.
Yes.
Right. So that's the amount. So 5.3 moles. Okay, so what is the next?
We calculate the another side.
6 multiplied by 5.3. Yes.
I don't know. Let's just think about that. So yes, it could be like that, but can you just rationalize why do we do so? Can you explain it?
to be nutrition.
I don't think.
Okay, so according the equation over here, so this is the equation which basically makes this reaction to happen. This is, let's say, we know that reaction goes this way, what is given here, right? Which tells us that 1 mole of glucose produces 6 moles of carbon dioxide. Okay?
Okay.
So it means that 1 mole corresponds to 6 moles. But how many moles of glucose we consumed?
5.3.
Exactly. So we consumed 5.3. So that's going to be X.
X.
Right. So this is why we need to multiply 6 times 5.3
Yes.
is going to be whatever it is. Can you just calculate?
28 by 5.5.
No,
Yeah.
it's going to be 31.8. No?
No,
It's 31.8.
Right. What is the
Yes,
unit?
right.
sorry. 31. Sorry.
It will be mole.
Oh, yeah, exactly. It's going to be moles. Okay, so what is the next? It says that what is the mass of carbon dioxide produced? So, okay, we calculated the moles, but this is not the mass, right? It's just number of moles. So how to find the mass?
We just find the molar mass of CO2.
Right. So what is the molar mass
And-
of CO2?
Yes. Just a second. Sorry.
44.
Yeah, it's going to be 44 gram per mole, right? Gram per
Yes.
mole. Now, from here, we need to calculate the mass of carbon dioxide produced, and what we should do.
We multiply the 31 by 44, I guess.
Yeah, so 31.8 moles multiplied by 44
Yeah.
gram
will
per
be
mole.
1,255 gram.
Okay, it's going to be 1,000 and then
255 gram.
255 grams. Yeah, so
Yes.
it's almost like it's 1.2 kilos of carbon dioxide. It's a lot of carbon dioxide produced.
Yes.
Okay, so is that clear what we did here?
Yes.
All right, so
Yes, clear.
let's just look at the next question. It's a quick question. Which of the following statements is correct for the equation shown here? And then it said 1 mole of NO is produced per mole of ammonia reacted. 6 grams of water is produced every 4 grams of ammonia reacted, and 2 moles of NO are produced for every 3 moles of water. Please look at this equation first, and then think which of these statements is correct.
A will be the right one.
Right, so the A will be the right one because you have 4 moles producing 4 moles, and obviously, so
moles.
1 mole will produce 1 mole is produced per mole of ammonia. So yeah, the first sentence is the right one. Yeah. Okay.
Can you explain?
Okay, so according the equation, so we need to look at this equation. According the equation, 4 moles produces 4 moles, right? So let's say 4 produces 4.
The same.
So then it says that 1 mole produces 1 mole. So the 1 mole will produce how much?
1 mole.
Yeah, 1 mole. So this is what does it say? So 1 mole of NO
Nutrition.
is produced per mole of ammonia. So this is why this sentence is correct.
He just asked for an ammonia.
Yeah, it just asks like it even doesn't ask anything. It just says that 1 mole NO is produced per mole of ammonia, and there are also some other sentences, but we just need to find the right one. We even don't need to calculate much. So if this is correct, it means that this is only the sentence which is correct, and this is correct because 4 moles produces 4 moles and 1 mole produces 1 mole. So it's the same thing is what is written here.
And we didn't to calculate hydrogen. Yes.
No, here we don't care about. There's no hydrogen here at all, so it's only oxide, nitric oxide, and water. So there's no hydrogen produced, and I mean,
Okay.
okay. So here is no. So we're talking about now about this one. Okay, we're not talking about like the previous. This is different reaction. So what is produced, it shows over here.
Yes. Yes. Thank you.
Okay, so let's just see what we have here. So we'll practice all these things, and let me see what do we have here. Okay, yeah. All right, so I have about 1.5 minutes left, but let's just finish this one. And I'll let you know about the quiz. If I think that it's not enough practicing, maybe we'll not have a quiz next time. So maybe we'll move it to the other week. Okay. Let's just see here. We have urea. This is a urea. And it's prepared by reacting ammonia with carbon dioxide. Okay, so that's the carbon dioxide. And we are producing, this is urea, and we are producing water. So it's going to be plus over here, plus. So, and it says that in process of, in this process, so we have ammonia, carbon dioxide, we produce urea and water. So in this process, we have 849.2 grams of ammonia, which reacts with a particular amount of carbon dioxide. And which of the two reactants is a limiting reagent? Okay, so it says which one is the limiting. So, and it says calculate the mass of ammonia, urea